This is the lecture for lesson 12. This section will be very short. The first part is about solving radical equations. Radical equations are, of course, equations that have a square root in them. So in order to solve these, we need to isolate the radical, make sure there's nothing else added or multiplied on that side, so that we can square both sides. We square both sides to get rid of a square root because they are operations that undo each other. Just like addition and subtraction undo each other, multiplication and division undo each other, square roots and a power squared undo each other. Starting with our first example here, we have the square root of 5x minus 1 equals 8. Our square root is isolated, so we can square both sides. I will square the right and the left. When I square a square root, they cancel out, leaving me with just 5x minus 1. 8 squared means to take 8 times itself, 64. Then we solve this like every other linear equation. Add 1. We have 5x equals 65, which I can, in fact, divide by 5 and get x equals 13. Next one, we have the square root of 2x plus 5 plus 11 equals 6. We do not have an isolated square root in this problem, so we need to first get rid of that plus 11 by subtracting 11. The square root of 2x plus 5 equals negative 5. Well, according to what we've learned, there is no way to take a square root of a number and come up with negative 5. Complex numbers, again, we're working with real number solutions here. Complex numbers don't count, okay? We can't do that here. We can't end up with something odd. We want to find real solutions here. So anytime we're doing these problems, we are looking for real number solutions. No I pieces. So we can never have square root cannot equal a negative. It's not going to give us a real solution. So this one has no solution. Please watch for those because they can come up. Why is it a good idea to isolate the radical term when solving a radical equation? What happens if we don't do this and simply square each side? Well, here's what's going to happen. If I tried to take this one for b and square both sides, I'm actually not going to get rid of the square root. So let me show you here. If I had the square root of x plus 5, and I wanted to square that, that means I'm going to multiply it by itself. Watch what happens. Square root of x times square root of x, so square root of x squared. Square root of x times 5, 5 root x. 5 times root x is 5 root x. And 5 times 5 is 25. Well, I can simplify square root of x squared and get x. I can combine these two together, 10 root x plus 25. But I didn't get rid of all the square roots. I, in fact, made more work for myself, and I still have square roots. Okay? So if you do not isolate the square root first, you, in fact, don't get rid of all your radicals. When not isolated, there are still radicals. This is easier. You're going to get easier pieces to work with. I don't want to do FOIL. FOIL is way more work, and it's not actually helping me in the end. Just like radicals, we can also solve equations with fraction exponents. If we have fraction exponents, it means we have radicals. So what we're going to do to solve a problem with fractional exponents is use a reciprocal exponent. Our first problem says x to the 2/3 equals 64. The way we solve these is by using the reciprocal power. So I'm going to do the 3/2 power to both sides. Here's why. When we do a power to a power, we multiply powers. Well, 2/3 times 3/2, 2 times 3 is 6, 3 times 2 is 6, 6 over 6 is 1. I then have no power on my x. On the right-hand side, we have 64 to the 3/2 power. Remember, the bottom is your radical or your root, and then the top is your power. So this means take the square root of 64 and then cube that answer. Well, the square root of 64 is 8, and if I do 8 cubed, I will get 512. So that means if I go back here and I do 512 to the 2/3 power, I will get 64. For B, we have x plus 7 raised to the 4/3 power equals 16. What I need to do is get rid of that 4/3 power. So the way I do that is I raise it to the reciprocal power, 3/4. That leaves me with x plus 7 on the left-hand side. And now on the right-hand side, this is the 4th root of the number cubed. So the 4th root of 16, and then I want to cube that. Well, the 4th root of 16 is 2. So that becomes x plus 7 equals 2 cubed, and 2 cubed is 8. So x plus 7 equals 8. Now, you could type this part here in a scientific calculator. You can type 16 to the 3/4 power, 16 caret open parentheses 3/4 power, and it should give you 8. If it does not, please come ask me so I can show you how to do it correctly in your calculator. We do need to finish solving. For x, I will subtract 7 from both sides. That is x equals 1. And that is the end of this section. If you have questions, make sure you ask me. You can go ahead and start the homework though.